Welcome to The Explainer. Today, we are going to crack the case on one of the most important tools in all of science and research, the hypothesis. Seriously, this thing is the starting point for just about every discovery out there, and we're going to break down exactly how it works.
So how do scientists actually prove what they think is true? I mean, it all starts with a hunch, right? A little question about how the world works. But how do you get from just a gut feeling to real, solid evidence? You can't just say something is true. You need a plan, a formal plan of attack to put your idea to the test. And guess what? That plan? It starts with a hypothesis.
All right, so let's get right into it. A hypothesis is not a fact. It's more like a specific, testable prediction about what you think is going to happen. Think of it as the main theory your detective, that's the researcher, is trying to solve. It's the big assumption you put right under the microscope.
Okay, so to really wrap our heads around this, let's use a real-world example. We're going to see how a simple question gets sharpened up into a testable hunch that science can actually sink its teeth into.
All right, check this out. Men earn more than women in the same job in Austria. Now hold on, this isn't just some casual comment or an opinion, right? This is a really specific claim. It's a statement we can actually go out and investigate by looking at the relationship between two key clues, or what researchers call variables.
So, what are these variables we're talking about? Well, a variable is just a fancy word for something that can have different values. So for our hunch, the variables are pretty clear, right? You've got gender, which can be male or female, and you've got income, which can be, any specific amount of money. So at its core, a hypothesis is just an assumption about how these two variables, are connected.
Okay, you ready for a little plot twist? Because this is where the whole investigation gets really interesting. In science, to prove your hunch might be true, you don't actually try to prove it directly. Nope. Instead, you have to challenge its complete opposite. So every investigation has these two competing stories. On one side, you've got the null hypothesis, which we call H0. Think of this as the boring default reality. It assumes nothing is going on, no difference, no effect. In our case, it's the idea that gender has absolutely no effect on salary. But on the other side, you have the alternative hypothesis, H1. And this is your hunch. This is the claim that there is an effect, that gender does have an effect on what people earn.
And this is so important, so listen up. Your goal isn't to prove your alternative hypothesis. Instead, your job is to gather enough evidence to reject the null hypothesis. It's kind of like a courtroom, right? The defendant is assumed innocent. That's the null hypothesis, until there's enough evidence to prove guilt. So you're trying to prove, beyond a reasonable doubt, that the boring version of reality just isn't true.
All right, so now we know the rules of the game. Let's start looking at the investigator's toolkit. There are a couple of main ways you can frame your hypothesis, and it all depends on the kind of case you're trying to build.
First up, difference hypotheses. This one's pretty straightforward. You use this when you want to compare two or more separate groups to see if there's a difference between them. And you can see it right here. We're comparing the group of men to the group of women. Or we could compare the group of smokers to the group of non-smokers. You're looking for a clear dividing line between these separate, identifiable groups.
Okay, next up in the toolkit, correlation hypotheses. This is what you pull out when you're not comparing totally separate groups, but instead, you're looking for a relationship, a connection, a pattern between two variables that can change together. And you can totally see the pattern in the language, can't you? The taller a person is, the heavier they are. The more horsepower, the higher the fuel consumption. It's always this, the more of X, the higher of Y kind of thing. We're not comparing distinct groups, we're just seeing how one thing changes when another thing changes. All right, let's get to our final tool. This adds one last layer of precision to our hunch. So after you've decided if you're looking for a difference or a correlation, you've got to decide just how specific are you going to be. So first, you have the non-directional hypothesis. This is kind of like saying, hey, I think there's a connection between these two things, but I'm not really sure if it's a positive or negative one. You're basically just saying, something is going on here. Just look at the wording here. There is a difference between the salary of men and women. But see, it doesn't say who earns more. Or there is a correlation between height and weight, but it doesn't say if taller people are heavier or lighter. It's just pointing out that a connection exists. That's it.
But if you're feeling a bit more confident in your hunch, you can use a directional hypothesis. This is when you're ready to make a bold claim. You're pointing your finger in a very specific direction, saying something like, this group is more than that group.
And you can see how much more specific this is, right? The words say it all. Men earn more than women, or the taller a person is, the heavier he is. Words like more, taller, heavier, they give the hypothesis a crystal clear, testable direction. You're not just saying there's a link, you're predicting exactly what that link looks like.
So, there you have it. You've got your hunch. You've picked your tools. You've decided on a direction. Now what? Well, now it's time to put this whole thing together into a formal case plan, a step-by-step process that any researcher can follow to get to the truth. And this is it. This is the roadmap every single researcher follows. First, you do your literature research. You got to see what other people have already found out, right? Then, you formulate the hypothesis, your very specific, testable claim. Next, you have to define the scale level. That just means deciding exactly how you're going to measure your variables. After that, you determine the significance level, basically deciding ahead of time how much evidence you'll need to be convinced. Then you pick your hypothesis type. Is it difference or correlation, directional or not? And finally, you choose a suitable hypothesis test. That's the specific statistical tool you'll use to see if you can finally, officially reject that null hypothesis. It's a whole process, but it's what turns a simple idea into actual science.
So there you have it. You've basically got the detective's toolkit now. You can take any observation, figure out the variables, frame the null and the alternative stories, and map out a path to the truth. So, take a look around you. What's a belief you hold that could actually become a testable hypothesis? Because once you have this framework, you start to see the world a little differently, not just as a bunch of facts, but as a series of really fascinating cases just waiting to be solved.